Before we delve into the hidden history of the World Wide Web, it's crucial to understand a fundamental distinction often blurred in popular accounts: the difference between the Internet and the web. The Internet is the foundation, the global network of interconnected computers. Think of it as the physical infrastructure, the fiber optic cables, the routers, the servers that allow machines all over the world to communicate with each other. Its origins as a packet switching network are undeniably American, stemming from projects like ARPANET. The World Wide Web, on the other hand, is an application that runs on top of the Internet. It is a system for accessing and sharing information, a universe of documents connected by hyperlinks. While the Internet is the plumbing, the web is the water flowing through it. It's the websites, the pages, the browsers, and the protocols like HTTP that allow us to navigate this information space. To understand the web's true origins, we must look past the usual figures. While pioneers like Vint Cerf and Bob Kahn were instrumental to the Internet, the conceptual groundwork for a global network of interconnected minds was laid earlier. Joseph Karl Robnet Licklider, in the 1950s, championed the idea of time sharing, a single computer serving many users at once, a concept dismissed by most as science fiction. His successful 1957 demonstration on a PDP-1 computer proved that such a man-computer symbiosis was possible. From this, the leap to connecting users beyond a single company's premises seems in hindsight a small one. The idea of hypertext, often attributed to Vannevar Bush's Memex, has deeper European roots. The common narrative often ignores that as early as the 16th century, European libraries were experimenting with mechanical book automata. A prime example is the bookrat, or bookwheel, designed by Agostino Ramelli in 1588. By typing a numerical code, a reader could have the machine automatically turn to a specific page in another book. This was information linking, 350 years before the digital age. From this perspective, Memex appears not as a revolutionary invention, but as a modernization of a centuries-old European idea. The true visionary of hypertext was Ted Nelson, who in 1960 conceived of the Xanadu project. His ideas were far more advanced than what we use today. He envisioned bidirectional links, allowing any document to know what other documents were linking to it. He imagined transclusion, the ability to embed a piece of one document into another, which would replace the chaotic spaghetti programming of today's web links with a more structured system. While the Internet was in its infancy in the late 1960s, a British engineer named Samuel Fedita had a vision that contained all the functional elements of the World Wide Web. Inspired by Licklider, he patented view data in 1968. A working prototype was running by 1974, more than 15 years before the WWW. It was launched commercially in the UK as Prestel and later adopted across Europe, known in Germany and Austria as Bildschirmtext, or BTX. Fedita's idea was revolutionary because it was pragmatic. In 1968, home computers didn't exist, but most households had a color television and a telephone. BTX was designed to connect these existing technologies. A simple decoder box connected the phone line to the TV, turning it into a network terminal. The remote control served as the keyboard. It was a system for the masses, built with the technology of the day. Though the graphics were rudimentary, based on mosaic characters, they were colorful and effective. One could send messages, functionally emails, long before the term was common. You could order products, make bookings, and participate in public discussion forums. Austria's ERDE from 1987 might have been the first nationwide public chat platform. The system had features the modern web still lacks. Every user had a known identity, making spam impossible, and it supported micropayments for content. Billed directly to your phone bill. an innovation developed by Hermann Maurer and his colleague Gerhard Greiner, even allowed for text entry using only a numeric keypad. By assigning letters to each number key, a user could type a sequence of digits like 20445. The system would then consult a dictionary and, leveraging the redundancy of the German language, correctly deduce the word hallo. This very same principle was rediscovered years later for sending SMS messages on mobile phones. While many countries adopted BTX, a team at the Graz University of Technology in Austria, Professors Hermann Maurer and Reinhard Posch, pursued a radical new idea. Instead of a simple decoder, why not use a fully programmable computer? This led to the creation of the MUPID. The name also hinted at their names, Maurer und Posch, Intelligenter Decoder. The MUPID was a true home computer, but with a revolutionary architecture. To overcome the slow and unreliable cassette drives of the era, all user data and programs were stored centrally on the BTX servers. This was, in essence, cloud computing and an app store decades ahead of its time. Users could download teleprogram to their MUPID to perform calculations, play multi-person games, or run information management software. The first true social networks were born on this platform. The programmability of the MUPID unlocked immense potential. One of the most significant projects was COSTalk, or Computer-Supported Teaching of Computer Science. The team developed over 300 one-hour educational units, complete with images, animations, and interactive quizzes. This was the first nationwide networked learning system, used by dozens of universities worldwide. Courses were authored by leading scientists, making high-level education accessible across the country through the BTX network. The MUPID BTX system even supported multi-user, real-time applications like telechess. Players could compete synchronously or asynchronously, and a chat function was built in. If no human opponent was available, the system would seamlessly connect you to a chess program that could even participate in the chat. This level of interactivity and networked capability, pioneered in Graz, would not be seen on the mainstream web for many years. So why did this advanced, feature-rich European system fail? The answer was multifaceted. The BTX central servers were expensive and difficult to maintain. But the biggest barrier was cost to the user. In Austria, using BTX for just 20 minutes a day could add the equivalent of €200 to a monthly phone bill. In contrast, users in the US enjoyed flat-rate local calls, making the emerging internet vastly more affordable. By the early 1990s, three systems were competing to be the future: the University of Minnesota's hierarchical Gopher, the World Wide Web from a team at CERN, and Hyper-G, later Hyperwave, a project by TU Graz. Hyper-G was by far the most powerful. It offered bidirectional links, which meant no 404 page not found errors. It had sophisticated metadata, search capabilities, and access controls, making it a powerful knowledge management system. The www, however, was the simplest. It was easy to install, and crucially, it was free. The turning point came in 1993 with the release of Mosaic, the first graphical web browser. Its user-friendly interface caused an explosion in the web's popularity. The conceptual elegance and power of Gopher and Hyperwave were no match for the simple, cheap, and suddenly very accessible www. The development, which had been European-led at CERN, quickly shifted. In 1994, the World Wide Web Consortium, W3C, was founded at MIT in the USA, and Tim Berners-Lee was brought over to lead it. When there was a meeting in Brussels to determine the roles of Europe and the US in the new W3C, there was no discussion. The American delegation presented a finished document that transferred nearly all rights and control to the US. When CERN's representative, Robert Calyau, objected, Another European organization immediately stepped in to accept the terms. In that moment, it was clear to all the Europeans in the room. The WWW had just become an American affair. The world voted for simplicity and low cost, and a chapter of European innovation was closed, too.